Okay, welcome to the Year 8 Chemistry Mind Map. And here, if you want to take a picture, you may before we move on. And we'll do that now. Now to move on, we'll zoom in. And we'll go up to the first part of the mind map, which is all about the atom. And we start off with one of my favorite science jokes, which is never trust an atom because they make up everything, before we move into what we call atomic structure, which is the structure of the atom. We see that all matter is made up of atoms. Right? Inside the nucleus, we put the protons, which have a mass of 1 and a charge of +1. We've got neutrons that have a mass of 1 and a charge that is neutral. And we have electrons that have next to no mass with a negative charge. And the electrons are found in electron shells that increase with energy. Here we have a diagram or a table to summarize these subatomic particles. Next, we move into the idea of the configuration of the electrons. Electron shells are energy levels and they increase in energy. The lower shells need to be filled before the higher shells, and only the outer shell electrons participate in bonding. The outer shell electrons are called valence electrons. The first shell holds 2 electrons, the second shell holds 8 electrons, the third shell holds 8 electrons, and so on. And as they get larger or higher up in energy levels, they hold more electrons. Right? For instance, calcium, which is element number 20, has an electron configuration of 2882. Now, it's true to say that elements always want to have a full outer shell, and to this end, they can't get rid of their protons, but they can change their number of electrons. But this messes with the charge of the atom. Atoms can gain or lose electrons to attain a full outer shell. Metals generally lose electrons to form cations that are positive, and non-metals gain electrons to form anions that are negative. All right, if we look down here at this diagram, we can see that cations are positive, and this cation has 5 protons in the nucleus and only 3 electrons on the outside, so it has 2 more positive charges than negative charges, so it has a charge of +2. Conversely, we have the anion here that only has 3 protons but 5 electrons, therefore it has 2 more negative charges than positive charges, and so the anion here has a charge of -2. Right. When we think about the grand scheme of things, here is oxygen. It has its atomic number at the top and its atomic mass down the bottom. It doesn't read 16 exactly because of the relative abundance of the isotopes, but in general we can round that to 16. So the atomic number is 8, the mass number is 16, the element name is oxygen, and the chemical symbol is capital O. It has 8 protons. It has 8 neutrons. 16 minus 8 is 8. Then the electrons, because oxygen here is not charged, it must have 8 electrons. Therefore, the electron configuration would be 2, 6. Okay, then let's move down to the periodic table. Now, in the periodic table, it shows all of the elements that are natural and man-made. The separation between natural and man-made is around uranium. Anything above uranium is man-made, and anything that is uranium or lower is natural. All right? In the periodic table, we can see that it's made up of all of the elements that exist. Elements are arranged in increasing numbers of protons. The protons are in the nucleus, and we call the atomic number Z, and the number of protons plus neutrons we call the mass number, which is A. The periodic table has groups which are along the top. So hydrogen is group 1, then we can see beryllium is group 2, then we have a lot of transition metals, then we have boron that is group 13, carbon that is group 14, nitrogen that is group 15, oxygen that is group 16, fluorine that is group 17, and helium there is group 18. Okay? Group 1 we call the alkali metals. They have 1 electron in the outer shell. Group 2 are called the alkali earth metals. They all have 2 electrons in their outer shell. Then we get across to here, we can see that group 18, the noble gases, They have a full outer shell of electrons and therefore are non-reactive. Group 17, headed by fluorine, has room for one more electron in its outer shell, and they are called the halogens. Okay, then we get down to the number of rows. The rows here are called the periods, and the rows indicate the number of electron shells. So we can see here that hydrogen only has one electron shell, whereas the row here that starts with lithium has 2 electron shells, with sodium has 3 electron shells, with potassium has 4 electron shells, and so on. Okay, then we get down to the chemical properties. Now, the chemical properties of the elements are determined by the numbers of electrons in the outer shell, which we know as the valence electrons. It's also determined by the size of the nucleus. But ultimately, it is determined by the distance of the outer shell electrons to the nucleus. We call this the electronegativity. Having said that, all elements have properties, have physical properties. The first one is electrical conductivity, which is the ability to conduct electricity. Then we have thermal conductivity, which is the ability to conduct heat. We have shininess, which we call luster. The ability to bend, we call malleability. The ability to be drawn into a wire, we call ductility. And its relative strength, we know as hardness. Then we get down to the nature of the substances. Now, substances either come in an elemental form, which is just the element by itself, or a molecule that is 2 atoms of the same element that are chemically bonded together. But then we can also have compounds, which are 2 or more different elements chemically bonded together. All compounds are molecules, but not all molecules are compounds. That is to say that a compound is made up of more than one element, but a molecule can be just one element. Over here, we've got a diagram on its side, and you should be able to work out which ones are molecules and which ones are compounds. And to break it to you gently, the ones here, chlorine, nitrogen, oxygen, and hydrogen, they are molecules, but they are not compounds. And here, on the second row, which is nitrogen oxide, water, nitrogen dioxide, and carbon dioxide, they are molecules, but they are also compounds because they are made up of more than one element. When it comes to chemical formula, the formula describes the number of each element in a compound or molecule. And therefore, all compounds have names. The prefix mono means 1, di means 2, tri means 3. Ionic compounds are made up of both metals and non-metals generally, but not in this case, which is ammonium carbonate. Right, a substance is deemed to be pure when the molecules cannot be physically separated, which means that there's only one type of molecule. A mixture is defined by the fact that the molecules can be physically separated, which means there must be more than one type of molecule. Okay, then we're going to scoot up to the very top on the other side, and we can see here that we're going to start with kinetic molecular theory. So all substances are made of matter. We can see that particles are constantly moving, and the fact that they're constantly moving, we say that they all have kinetic energy. The higher the temperature, the more the particles move. Therefore, we can say that kinetic energy is proportional to temperature. All right, if we get down to the 3 states of matter, we have solids that are of the lowest energy, and the particles are standing in place, vibrating against each other. Then we have liquids, which are of medium energy, and the particles are vibrating, but they're also sliding past each other. Then we have gases that are the highest energy, and the particles not only vibrate, but they zoom past each other, and they collide with the sides of a vessel that we know as being pressure. Okay, then we get on to the states of matter. The states of matter is dependent upon the temperature or the energy. When energy is added, the temperature increases. When the temperature rises, the kinetic energy of the particles also rises. As the kinetic energy increases, the bonds holding the particles together are broken. This allows for the change in state from solid to liquid to gas. When energy is removed, the opposite occurs and we go from gas to liquid to solid. Here is a beautiful graph that you should all know that shows you the amount of heat supplied versus the temperature. Down here we have solids, and solids, as they're heated, will increase in temperature up to a point. Even though the heat is still being applied, it will not change temperature as we undergo the change of state. In this case, going from solid to liquid is called melting. All right, then as we add more energy, once it's all turned to liquid, the temperature of the liquid will then increase, but then it will stop. And then we get from liquid, this isn't right, this is because this should not say melting, this should say evaporation. All right, and then as it evaporates, it turns into a gas, and then the temperature will increase again. Also, if you've got a gas and you're cooling it down, it will then condense into a liquid, which the temperature will then drop, but it won't condense again. It will now freeze, and then as it freezes, it becomes a solid. Okay, it's always good to find errors in diagrams on the internet, isn't it? Now we move on to pressure and density. All right, with pressure, the collisions with the side of the vessel are of super importance. As heat increases, the kinetic energy increases. As the kinetic energy increases, the velocity increases. As the velocity increases, the number of collisions increase. And as the number of collisions increase, the pressure also increases, because pressure is the number of collisions with the side of the vessel. Here we can see a relationship between an increase in temperature with an increase in volume. All right? That is because we have a higher number of collisions, therefore increasing the pressure. And here we have a graph that shows you in Kelvin. Remember, Kelvin minus 273 Kelvin is absolute zero. But as we increase temperature, the volume of any substance will increase. And therefore, if the volume is increasing, the pressure is increasing. Now we have density, which is the amount of matter per unit volume. So D equals M on V. As heat increases, the kinetic energy increases. As the kinetic energy increases, the velocity increases. As the velocity increases, the space between the particles also increase. And when the space between the particles increases, density decreases because we've got less matter per unit volume. Okay, this lovely table, this lovely diagram here illustrates it perfectly. Now we're getting on to the changes in matter. Now the changes in matter can either be physical or chemical. A physical change is just a change in state. It can easily be reversed and no new substances are formed. However, a chemical change cannot be easily reversed because new substances are formed. The molecules that are used are called reactants. The molecules that are made are called products, and therefore we can say that reactants become products. In reactants, the chemical bonds are broken, and in products, the chemical bonds are made. And Lavoisier told us that matter cannot be created nor destroyed, only transformed. Last of all, we have rates of reaction, which is how quickly a reaction takes place. A rate is the amount of product per unit time, and the rate is dependent upon the particles being able to collide. The more collisions, the higher the rate of reaction. And therefore, how do we increase the number of collisions? Well, first of all, we can increase the surface area to volume ratio. That will give us a higher rate of reaction. We can have a higher concentration. That will also give us a higher rate of reaction. We can increase the temperature, will also give us an increase in the rate of reaction. We can increase the pressure. That will also give us an increase in rate of reaction. Or we can expose the reaction to a catalyst, and the catalyst will also increase the rate of reaction. Thank you for listening. We'll zoom back out again. All right, in case you wanted to take another snapshot, it's completely up to you. Feel free to use it. I hope you've enjoyed it, and thank you for listening.